Welcome to Reshaped Technologies' 7 stunning discoveries of 2025 that reshaped science, energy, and reality. If you missed the science stories that truly mattered in 2025, start here. Scientific discovery rarely arrives in a single dramatic moment. It usually emerges through careful experiments, revised equations, unexpected field observations, and years of incremental progress. In 2025, that convergence became especially visible. Across physics, energy research, materials science, biology, and archaeology, researchers reported findings that reshaped long-standing assumptions, from how close we are to fusion power to whether reality itself could ever be simulated. Some of these discoveries solved century-old problems. Others revived species thought lost to time or revealed sophisticated societies that are older than written history. Together, they offer a snapshot of how human understanding continues to evolve at every scale. Here are 7 discoveries from 2025 that stand out not for spectacle, but for the depth of insight they add to our understanding of the world. 1. Mathematics proves the universe isn't a simulation. One of the most provocative ideas of our times, that reality could be a computer simulation, took a serious hit in 2025. This year, physicists and mathematicians showed that even simulating a relatively small quantum system, such as a few hundred interacting electrons, would require computational resources larger than the known universe itself. The key problem is scale. The computational complexity of quantum systems grows exponentially, not linearly, meaning the processing power needed quickly becomes physically impossible under known laws. The study argues that a matrix-style simulation would violate fundamental constraints of physics, particularly those on energy, information storage, and computation. In simple terms, no universe-sized computer could exist within the universe it is simulating. While the work does not rule out philosophical thought experiments, it provides a rigorous mathematical argument against physically realizable simulations of reality. The findings impact physics, computer science, and philosophy, grounding a speculative idea in hard, natural limits. 2. A one-step method converts plastic into fuel at 95% efficiency. A joint US-China research team unveiled a major breakthrough in chemical recycling by developing a single-step process that converts common plastics directly into liquid fuel with up to 95% efficiency. The method targets polyolefins, plastics widely used in packaging and consumer goods, and avoids the multi-stage, energy-intensive steps that have long plagued plastic recycling efforts. Unlike traditional approaches that require high temperatures and produce inconsistent outputs, this one-pot catalytic process operates under comparatively mild conditions and yields high-quality fuel products. Researchers say the method could significantly reduce plastic waste while creating a viable energy output, addressing 2 global challenges simultaneously. While large-scale deployment will depend on economic and infrastructure factors, the chemistry itself marks a leap forward. It demonstrates that plastic waste need not be downcycled or landfilled. It can be transformed into a usable resource with minimal processing. 3. Poland's 5,500-year-old pyramids reveal elite Neolithic burials. Archaeologists in Poland uncovered 2 massive tombs, hidden within megalithic structures, often referred to as Polish pyramids, dating back roughly 5,500 years. Built by the funnel beaker culture, these elongated trapezoidal monuments predate the Egyptian pyramids and rank among the largest prehistoric structures ever found in the region. The discovery is especially rare. Only 2 similar tombs had been identified in Poland since the 1930s, making these the 3rd and 4th known examples in nearly a century. Researchers believe the structures served as elite burial sites for leaders, priests, or shamans, challenging earlier assumptions that funnel beaker societies were strictly egalitarian. Constructed using stones weighing up to 10 tons and aligned with cardinal directions, the monuments suggest advanced spatial planning and possible astronomical knowledge. 4. A living fossil mammal resurfaces after more than 60 years. In Indonesia's remote Cyclops Mountains, researchers confirmed the survival of Attenborough's long-beaked echidna, an egg-laying mammal lost to science for over 6 decades. Using camera traps, scientists captured definitive images of the elusive species, one of only 5 monotremes known to exist. The echidna is often described as a living fossil because it retains ancient evolutionary traits, combining reptile-like egg-laying with mammalian characteristics such as fur and milk production. Its rediscovery is extraordinary in modern zoology, where most large terrestrial mammals are already well documented. The find confirms that the species endured despite habitat loss and human pressure, though it remains critically endangered. Beyond conservation implications, the rediscovery provides a rare opportunity to study early mammalian evolution and the biological pathways that shaped modern mammals. 5. World's largest stellarator achieves a fusion milestone with helium-3. Scientists operating the Wendelstein 7X stellarator in Germany reached a major fusion milestone in 2025 by producing high-energy helium-3 ions for the first time. Using ion cyclotron resonance heating, researchers successfully simulated the behavior of alpha particles, which are essential for sustaining the extreme temperatures required for continuous fusion reactions. Stellarators differ from tokamaks by using twisted magnetic fields to stabilize plasma without relying on large internal currents, potentially offering steadier long-term operation. The helium-3 breakthrough helps scientists understand how energetic particles behave in fusion plasmas and how to prevent energy losses that can shut down reactions. Beyond fusion power, the same resonance processes may explain mysterious helium-rich particle clouds observed on the Sun. The achievement marks a significant step toward viable, low-waste fusion energy and deepens our understanding of plasma physics both on Earth and in space. 6. A new polymer forms the strongest armor ever engineered. U.S. scientists created a new polymer material featuring an unprecedented density of mechanical bonds, about 100 trillion per square centimeter, by interlocking molecules in a chainmail-like structure. Unlike traditional materials that rely primarily on chemical bonds, this design uses mechanically interlocked connections that distribute force across the structure. The result is a material that is both lightweight and extraordinarily resistant to deformation, capable of dispersing immense kinetic energy. Researchers believe it could outperform existing armor materials while remaining flexible and thin. Beyond defense applications, the polymer could influence aerospace engineering, protective equipment, and structural materials, where strength-to-weight ratios are critical. The discovery represents a fundamental advance in materials science, demonstrating how molecular architecture, not just composition, can redefine physical performance limits. 7. A century-old math problem unlocks wind turbine efficiency. A graduate student in the U.S. revisited a 100-year-old aerodynamic problem first posed by British scientist Hermann Glauert and developed a missing mathematical solution that improves how wind turbine performance is modeled. By applying the calculus of variations, the research addressed limitations in Glauert's original framework, which focused solely on maximum power output while overlooking the structural forces acting on turbine blades. The new model accounts for bending moments and thrust loads, enabling more accurate predictions of real-world turbine behavior. Even small efficiency gains, around 1%, can translate into significant increases in energy output at scale, potentially powering entire neighborhoods without changing turbine hardware. The work has been published in Wind Energy Science and is expected to influence future turbine design and engineering education. It's a reminder that revisiting foundational mathematics can still unlock meaningful advances in modern renewable energy.